Good morning, calculus students. So, Mr. Chen again. So, today I would like to continue to talk about the other sections of 9.4. So, it's the direct comparison test and limit tests. So, direct comparison tests. So, let 0 is less than or equal to a sub n, and a sub n is less than or equal to b sub n for all the values of n. N normally it's a natural number. It's like 1, 2, 3, 4, 5, all the way to infinity. So if sigma of b sub n from n equals 1 to infinity converges, then sigma of a sub n equals 1 to infinity, also converges. Okay? So this one, it's just like a conditional statement. So one thing that you need to recognize here, so b sub n, it's always greater than or equal to a sub n. And then if the other way around, so a sub n diverges, so if that's the smaller term, the smaller series, the sequence diverges, then sigma. So that means for b sub n also diverges. So determine whether the series 5 over 2n squared plus 4n plus 3 converges or diverges. So one thing that you need to set up here, so the one that's given, it's considered a sub n. Or it could be b sub n. So it depends on which one that you're talking about. So we need to set up the similar series. So let's say something that it's greater than the given series. So the one that's given, it's a sub n is 5 over 2n squared plus 4n plus 3. So for b sub n, I want to set up something that is 5 over, or just consider 1 over n squared without the coefficient. So you might be wondering, why do I set up just like 1 over n squared? Because this one is all about the n behavior. So the n behavior, the highest power here is 0. So the lowest power here, the highest power in the denominator, it's square, okay, quadratic. So without the coefficient, so obviously b sub n is greater than a sub n. Okay, so try to come up with that, some of this term here. So let's say a sub 1, b sub 1, compare that. So this one will be 5 over 2 plus 4 plus 3, which is over 9. And then over here, so that just consider 1 over 1. Okay, obviously 1 over 1 is greater than 5 over 9. So let's prove that the series of b sub n, so if this one converges, so that means a sub n also converges by using the comparison test. So we do know that this one, it's a p series. By using the p series test, so p is 2, which is greater than 1. So therefore, so b sub n converges. So therefore, also by using the comparison test, direct comparison test, so that a sub n converges as well. So 2n squared plus 4n plus 3. Okay, so pretty simple. And now let's try another one. So what about this one here? So this one, again, you can set that as either a sub n or b sub n. So let's say that this one is considered, I would say that it's a b sub n, because I want to set up the similar series. So the other one, a sub n, this time, that would be considered 1 over n. And according to that, the direct comparison test, if a sub n diverges, then b sub n diverges as well. Okay, so since we set up that a sub n, the series, well, we do know that it's a harmonic series. So obviously this one diverges by using either the integral test. So we talked about that for the last video, the integral test to prove that the harmonic series diverges. Integral test or the harmonic series. So that means sigma a sub n diverges. So if a sub n diverges, then b sub n diverges as well. Okay, so notice that to use the comparison test, one of the following must be true of the term we test. So the term of the series must be smaller than those of a divergent series. The term of the series must be larger than those of a convergent series. So be careful when using the direct comparison test, like this one here. So a lot of students might be considered, well, the other similar series would be sigma 1 over 2 to the power of n. And then for the previous video, we proved that the exponential function by using the integral test. So this one, it's going to be considered exponential decay. So for the function, so let f of x okay, so let f of x equals 1 over 2 to the power of n. So by using the integral test, so we do know that this series converges. But keep that in mind. So if the smaller term of the series converges, it doesn't mean that the larger term of the series converges, okay? So you got to be very careful for this one here. I would say that this one is considered a sub n, and then the original one would be b sub n. Okay, so you want to prove that. So this one actually converges, but by using the comparison test, this one, it doesn't fit to the comparison test because that a sub n, it's actually less than b sub n. So this one is just saying that the smaller series converges. It doesn't mean that the larger series converges. Okay, so I got to be very careful with that one. So direct comparison test and the limit test. So what happens if that we can use the direct comparison test, we can use the limit comparison. So suppose that a sub n is greater than 0, b sub n is greater than 0, and the limit of n goes to infinity, of that the ratios a sub n over b sub n equals L, the finite number, the limit, where L is positive and finite, okay, positive and finite, okay, not infinity. Then two series, a sub n, b sub n, either both converge or both diverge. Okay, so like the previous one, if you try to use the direct comparison test, it doesn't work. So we need to use that the limit comparison test. Again, so for that a sub n, we just set that as 1 over 2 to the power of n. And then for b sub n, we set that as 1 over 2n minus 1. So using that, the limit comparison test, we do have limit as n goes to infinity. So a sub n, 1 over 2 to the power of n, all over 1 over 2 to the power of n minus 1. So you might be wondering, what do we do with this? This one is just like a complex fraction. So we can just put it this way, 2 to the power of n minus 1 over 2 to the power of n, multiplied by the reciprocal. And this one can be written as 2 to the power of n times 2 to the power of negative 1, which is 1 half. And then this one is just 2 to the power of n. Reduce, reduce. As you can see that the limit, it's going to be 1 half. So 1 half, is that considered positive? It is. Is that a finite number? It is. So therefore, so both series converges. So therefore, so first, both series, a sub n and b sub n converges. Converge, okay, because that's plural. So got to be careful with that, the limit comparison test, when you have to use it, when do you have to use the direct comparison, okay? So that's it. So there's more examples for the practice packet there, so you guys can work on. So we'll talk about that next time. Okay, so I'll see you guys for the next video. Okay, have a great one.